Teacher Murad Sultan Ezouidi again with you, the pioneers in math. I'm looking for you to, let's say, getting getting ready to join the lecture, okay? And through this through lecture, I'm going to revise, let's say, revise some questions from the final exam, okay? And I'm gonna let's say train you how can you let's say how can you be confident while solving, okay? I'll just okay, I'm going to see what can you do exactly. Let's say be confident while solving. Okay, I will extend this one. Okay. Now, learners, I'm going to share, let's say, my document with you. Okay, I will share this one with you. Share screen. Okay, yes, like that. Share my system. I will see how it works first. Okay. Now, if we continue, learners. Okay. We told that we are going to solve some questions. Okay. Yes. Okay. So, how can we start exactly? Now it's new the link, learners. Okay. And I wish that you can, let's say, join your lecture online. Okay, just wait for me. I'm going to share this one with you. Okay, share with you. Okay, learners. I tweet this one. Okay, your lecture status. Your lecture. Your online vision status. So just join your pioneer in maths, pioneer in math, Murad, Sultan, Ezouidi, HSM. Okay. Now, learners, we start. We talk about that today. We should at least solve some questions. Okay. I will start from this first. Okay. Okay. Let's do this exercise first. We have the question determine the range of values of x for which y is decreasing function. Okay. So learners try to think of this question. Okay. This kind of questions always will come in the final exam. Okay, so first of all, the first I should, let's say, differentiate my function y. Okay, but it's already differentiated, so we are going to solve or set y dash equals 0. I will just write here set y dash equal 0. Okay, therefore you are going to find all the stationary point, okay, that occurs on this curve, and then you are going to construct a table of values, and you will, let's say, choose some value of x, and you will check the sign of y dash. If it is positive, so the function is an increasing function. Okay, if it is negative, it will be the decreasing function. Okay, and therefore, through this table of values of x and sine of y, you can conclude exactly the range of values of x for which the function is increasing or decreasing. Okay. Now, learners, I will just write this as dy with respect to x. I'm going to start dy with respect to dx with respect to x is in fact equal 12x square, 12x square minus 4x cubed, 12x square minus 4x cubed. Okay, therefore this one should be equal to 0. Okay, to find the stationary point, equal, okay, to the power 3 should be equal to 0. Therefore, learners, here I'm going to find the value of x. You can see that 4x squared is a common factor. I will just write this as, okay, this will give me exactly 4, okay, 4x squared is a common factor of the terms of x, okay, x squared, okay, between parentheses. So 12x squared divided by 4x squared is 3. I'll just write here a 3. Then minus x, then close the parentheses. This one equals 0. Therefore, learners, you can see that 4x equals 0 or 3 minus x equals 0. I'll just write this again. Therefore, okay, therefore this will give me exactly, this implies that 4x squared is equal to 0, or let's say 3 minus x equal to 0. Therefore, 4x equals 0 means x is equal to 0 and x equals 3. As a conclusion, I will conclude, the roots of this function, it will be x is equal to 0. It's between parentheses a double root, okay, double root, okay. Then an x equal 3, a single root, okay, and x equal 3. So therefore, learners, this is in fact learners, the stationary point occurs at x equals 0 and x equals 3. I'll just write like that. As a conclusion, the stationary point occurs here at x equals 0 and x equals 3. Okay. Now, learners, what's remaining to do is that you should, let's say, construct a table of values and check the sign of y dash. Okay. Means that I will try to insert some, okay, like that. I hope so. This one will work. Okay, that works. Okay, this is white. So this is values of x. Okay, and here the sign of what? Sign of y dash. This is sign of y dash. Okay, this is the sign of y dash. The first derivative will be y with respect to x on just y dash whatsoever. Okay. Now, learners, I will consider, let's say, some points. I'll make it like that. Copy. Okay. Now this one, it will be the value of x that I will choose. Okay. Here we have, in fact, 3 roots, x equals 0 repeated root, and x equals 3 is non-repeat root. So it's the root of my equation y dash equals 0. Therefore, here I will just make it small if it's possible. Okay, like that. Then I will raise this. Okay, also here I will make like that. Okay, so I will make it small, learners. Okay, and this is should be also erased. I'll put it here. This is the table of values. So we told we'll just I'll put this here. Okay, this is my table of values. I will put here some value. We told x equals 0 and x equals 3. So this is x equals 3. This is x is equal to 3. And this one is x equals 0. X equals 0. Okay, I'll put it here. Then I'm going to choose, let's say, numbers between 0 and 3 and numbers below 0 and numbers above 3. Meaning that I'll make like that. So this one I put it here. This is when x, for example, equals 4. I'll choose 4. Then I will choose this number, which is x equals 1, for example. So x equals 1. Okay. This is x equals 1. And here, x is minus 1 is negative. Now, learners, I will check now, test, or test, let's say, the sign of the function dy with respect to x. If it is positive, when x equals negative 2, therefore the function will be decreasing function. If it is positive, it will be an increasing function. I will just continue proceeding like that. Okay. I will just extend this if it is possible, or I will use, okay, I will control V. I will use this one. Now this where to check or test the sign of the function. Therefore, learners, y dash is that. Okay. I'll just write it here. This is the function. Okay. Now we check when at x equal, for example, x equal 1, x equal minus 1. Therefore, dy with respect will be equal to, okay, just placement, will place x with minus 1. So d1 with respect to x when x, okay, or at between parentheses at x equal negative 1 is equal to 12 multiplied by negative 1 square, negative 1 square, okay, plus or negative 4 multiplied by negative 1 to the power negative 1 to the power 3. Okay, now just calculation of this. It will be 12, okay, plus 4. 12 plus 4 is 16. So 16 it's positive. It's positive, learners. Okay. It's greater than 0. Okay. It's greater than 0. Okay. Means it's positive. Therefore, at this, let's say this interval from 0 to negative 1, function is positive. I'll just write here. I'll come here and I will write the sign of dy with respect to x. I'll just write it here. This is learners is positive. Okay, the sign here is positive. Okay, and the function is an increasing function. Okay, so I will insert the symbol that show me the function is, in fact, is increasing. Okay, like that. Okay, this is the first step. Okay. Now learners, sorry. Okay. Now we move to the next part. If we suppose that I will use all of this, I will make a copy, then I will extend this one. Okay, like that. I will come to continue. I will write this one. I will go down learns, so the steps are very clear for you. Now at x equals 0, I will check. We check, let's say, x equals -1. At x equals 0, the first derivative value should be equal to 0 because it's a stationary point occurs at this point. Now I'll move immediately to x equals 1. Okay, means that you should find the value of the first derivative of the function at x equals 1. Okay, therefore it will be 12 multiplied by 1 square minus 4 multiplied by 1 cubed. Okay, so this one you can calculate it. 12 multiplied by 1 square is 12 minus 4 by 1 cubed is -4. It will be 12. Okay, this is 12. Therefore 12 learns is positive. Now I'm going to check. Okay, this is we call this positive. Okay, I will make Control V. Okay, at this point the function is positive. Okay, and this one comes here. Okay, now I will, let's say, make like that copy, and also this one will be like that because the function here is increasing. Okay, now move to the next part. If we suppose that I will just extend this one, so I will gain, let's say, space. Okay, I will do like that. Now the next case, the third case, is that sorry, Mr. Murad. Okay, is that when x equals 4, I'll check the sign of dy with respect to x. Okay. Therefore, when x equals 4 here, okay, I'll just let's say erase this one. Okay, no problem. I'll do like that. Okay, I will make it smaller so I can make 12, 10, whatsoever. 10, okay. Now when x is equal to 4, okay, I will calculate exactly the value of 4. It will be 12 x equals 4. This is very important to this. When x equals 4, the first derivative of the function will be 12 4 squared minus 4 multiplied by 4 cubed. Okay, so this one, in fact, 16 multiplied by 12, 16, we told multiply by 12, 16, I'll just write 16, 16 into 12, minus 4 into 64. So this one gives negative 64, equal to negative 64. Okay, negative 64. And this one learns, in fact, is negative. Okay, so is negative. What is negative sign? Is negative. Therefore, at this one, I will just copy this, Control V. So this one learns, it will be negative. Okay, I'll just write here sign, negative sign. Then I will erase the rest. Okay, this is the negative sign. I will make it bigger if it is possible. Okay, 12, 16, okay, 16. So now I will draw or show you the how the function is decreasing. Okay, the function now is decreasing function. Okay, I will just erase this, no need. Okay, Now learners, it's clear that I finished in fact solving this question, meaning the question has the interval of the range of values of x for which the equation is, say, the question is looking for decreasing function, I thought, okay, is yes, decreasing. So you are going to tell that x is more than or equal to 3. Okay, more than or equal to 3. Therefore, okay, I will just write this in the beginning. Okay, I will just continue like that. Okay, now learners, the range is equal is between parentheses the range between one, not the range is what here is the interval x is more than or equal to 3. So is x more or equal to 3. Okay, this is in fact the range for which the function is a decreasing function. If we suppose that the question is looking for find, let's say, the range of values for which the function is an increasing function, so we are going to tell that x is less than or equal to 0 and x is between 0 and 3, okay? Means in fact that x is less than or equal to 3, the function here is an increasing function. Okay, what else? Now we move to the next part. If it is possible, I will just save this. Okay. Now learners, we continue. We told that. Okay, we told that. Yes, question 4. If sine of a equal 12 divided by 13, cosine of a is 5 over 13. Sine of b is 8 divided by 10, and cosine of b is equal 6 over 10. Calculate the tangent of a minus b. Okay. Therefore, learners, I will just try to. Okay. I will just. Okay. I will just, let's say here. I will take this one if it is possible. Yes, I will use this one again. Copy. Now it comes down here. This questions really are very important. It will help you, let's say, thinking and evaluate the correct answer. Okay, let's start here. This question is of 3 marks. I will write first of all tangent 10 of a minus or a plus b. Okay, a plus b. Okay, let's see the formula. It will be equal. Okay, I will erase this one. Equal what is equal tangent of a plus tangent a plus tangent, let's say b, okay, divided by the product, by 1 minus the product, 1, okay, minus 10 a minus 10 b, okay, this is the formula. Now if we go, this is about the, let's say, about the sum of 2 angles. Okay. Now the question here is looking for you to find tangent of a plus b. So this one, just let's say replace as or put plus negative b. Okay. Therefore, this one will give me exactly. Okay. Will give me, if we are going to change a b with minus b, it will obtain like that. Tangent of a plus negative b between parentheses. Okay. negative b. Okay, then it will be tangent of a plus tangent of negative b. Okay, and there's this one. Also, this is tangent of negative b. Okay, but you know that tangent, you already know that. You know that tangent of minus b is equal to minus tangent of b. So you or this technique, this formula should be noted, or tangent is equal to negative tangent of b. Okay, so this formula should be, or it comes from the trig ratio of tangent, sine over cosine, okay, because sine is an odd function and cosine is even function, okay. Therefore, I will use this one, okay. I will use this one, learners, the last one, okay. So, yeah, this one also can be written as, I'll just write it here, okay. So, this one is equal tangent of a minus b, in fact, plus negative is minus a minus b. I'll just now raise this one equal. Okay, it will be tangent of a minus tangent of b. Okay, of b. Then minus multiplied by minus gives positive. Okay, plus 1 over tangent. So this is the formula. Therefore, learners, you can see that tangent of A is sine A over cosine A. It will be 12 divided by 5. Okay. So you can write your answer as a decimal or as a fraction. So we are going to write 12 over 13 or divide by 5 over 13. So it will be 12 divided by 5. 12 divided by 5 is 2.4. So tangent of A, now learners, is equal, I'll just write it again, okay. So this one is equal to what exactly? The total tangent of A is sine of A divided by cosine of A, okay, which is equal to 12 divided by 5. I can write here 12 divided by 5, okay. So that will never be confused. 12 divided by 5, okay. 12 divided by 5, simply because the hypotenuse will be cancelled. And tangent of B is sine of B divided by cosine of B. It will be A divided by 10. They all divide by 6 over 10. Therefore, the 10s will be cancelled, and the common factor, if it is possible, you will write as 4 over 3 or write as 8 over 6. So just write this as, okay, minus, we told you here is minus what? Minus 8 over 8 divided by what, learners? By 6. Okay, you can simplify as I told the common factor, you can write it as 4 over 3. Okay, therefore, now 1 plus tangent of A, which is 12 over 5. Okay, I will write here 12 over 5. Then multiply by tangent of B is 8 over 6. Okay, I will write here multiply by 8 over 6. Then I should simply, let's say, remove the tangent of B. Now, learners, it's clear that, let's see the last answer. If you use a calculator, you can also make it as that equal. Okay, here I will just I use this one again, or as you are going to use calculator, you will change the fraction into decimal number. Okay, it will be what exactly? I will write here equal. Okay, so 15 12 over 5 is 2.4 minus 8 over 6. 8 divided by 6, it will be 1.3 and so on. Okay, divided by 1, okay, plus plus 12, let's say 12, 12 multiplied by 8, okay, divided by 30, it will be 3.2, okay, 3.2. Therefore, 3.2, therefore learners, 3.2, therefore learners, just you will calculate this, I'll just write it as, now I'll make it 2.4, okay, 2.4 minus 8 divided by 6, okay, divided by, between parentheses, 1 plus 3.2, so approximately equal to 0.25, approximately equal 0.25, okay, okay, 2 to 1, to 2 decimal places. Okay, this is how can you answer these questions, learners. Okay, now if we continue, learners, I will just write this as that. It's clear, I thought. It's clear enough. Okay, and this kind of questions are absolutely, let's say, sure it will come, okay, but with different ratios. Okay. Now, learners, we move to the next part. You see the techniques that we use. This is a tangent of minus b is equal to negative tangent of b cosine of, because in fact tangent is not function, or we'll tell that equal sine of minus b over cosine of minus b. Sine of minus b is minus sine of b. Cosine of minus b is cosine of b, and it will be minus sine of the angle B over cosine of the angle B, which is minus tangent of B. Okay. So either in the final exam, if you will just write this value 12 over 13 in your calculator and divide by 5 over 13, and you write the answer here, no problem also, it will be correct. Okay. But don't forget about the steps, please, because they are very important. Okay. Now we move to the next question. Okay. The question is that I will use this again. Yes, I will use it. No problem. So learners, we'll try to focus on the second question. Okay. Question 6. We have y equal 1 minus exponential minus x divided by 1 plus exponential minus x. Okay, so the y in fact is written as u divided by v. Okay, I'll just insert a place where can I explain this question. Okay, so like that, I will make a yes. This is y, learners. Okay, this is the y. Copy. Therefore, learners, to differentiate this, you should know that I will just write here if okay, if I'll just write it here. Okay, no problem. If y is equal u divided by v, okay, u divided by v means that you are going to use the product, the quotient rule. Okay, therefore, learners, y dash or dy with respect to x, y dash. Okay, I'll just therefore, or this will give that. Therefore, okay, dy with respect to x is equal to, okay, I will use this one again. I will make the first derivative of the function u multiply v multiplied by u dash. Okay, then minus now v dash multiplied by u. Okay, all divided by what? By v squared. This is the formula in general. Okay, v to the power 2. But here in this kind of questions, just you will tell that u, okay, is 1 minus exponential minus x, and v is 1 plus exponential minus x. Therefore, I would suppose that let, the question is let that u equal exponential 1 minus, this is the function u. Okay, this is the function u. And therefore, okay, and v is, and let also v equal, okay, let also v equal, let's say, 1 plus exponential minus x. Therefore, to find the first derivative of the function, we will apply this one. And first of all, I should differentiate the y function. I will make there here is y dash or dy with respect to x whatsoever. It's called u dash, sorry. U dash is equal to what? Look, when the first derivative of a constant is 0, and you should differentiate, let's say, the minus exponential minus x. The first derivative of minus x is minus 1. Multiply by 1, minus 1 gives positive, so it will be exponential of minus x. This is the first derivative of the function u. Okay. Now we move to the next part. I will not try to differentiate this one as v, I mean. Okay, this is v. So therefore, v dash, I will differentiate v with respect to x of this function. The first derivative of minus x is minus 1 multiplied by the function exponential minus x. So it will be like that. But let's see, the minus sign isn't in here. Now, I already say find my first derivative of the function. Now I will apply the formula. I mean is what? I will apply this one. Okay, I will use this. So therefore, learners, this will give me, in fact, okay, dy with respect to x is v multiplied by du with respect to x minus the first derivative of the function v with respect to x multiplied by u over v squared. Okay, so this one, I'll write it again here, which is equal to, okay, so v is what here, learners? V is that, I will write my function v. This is v multiplied by the first derivative of the function u. Okay, between parentheses, this is the function v. Okay, multiplied by u. U dash is what? Is exponential minus x. Okay, multiplied by exponential minus x. Then I will raise this one. Then learners, I will just extend this as possible. Then minus v dash, this is v dash, sorry, this is v dash. Okay. Now you see this minus, I will put into parentheses the function, the first derivative of v dash. I will raise this multiplied by u. U is what? Is 1 minus exponential of minus x. Okay. I will open parentheses here. Then I will paste this and I will cut this one. Therefore, learners, okay. Therefore, sorry. Okay, yes. Therefore, now divided by what? By exponential of v square, which is 1 plus exponential minus x all square. Of course, you should write it into parentheses. Okay. I will delete this one. Okay. Now I already, let's say, approximately I finished the work, but just calculation, simple calculation. Okay. Now you can see that exponential minus x here, and here exponential minus x here can be a common factor. Okay. Or just you will continue like that. Okay. Can I, let's say, I'll make small? I don't know what can I do exactly, but I will make like that. Okay. Now, learners, I will go to this one. Okay. I will simplify now. I will make dy with respect to x is that, or y dash. Copy. Then I will go here to complete the question. What is the question? This is the question, okay. I will make like that to appear the question exactly is, okay. Let's see small a, then I will see small b, or I will go down. Go. Now I will get back to this. Okay. I wish this one is clear for you, learners. Okay. Sounds like we make small, press F. So we told that comes here. Okay. Where it was. Okay, just a moment. Here, okay. Now I put here this one. I would see the question is coming. Okay, I will cut. Okay, cut. I would see exactly where I wrote the question. I will paste it again. Okay. The question. This is the second question. A, B, find again. Okay, this is I will label as B. Okay. Now this is the whole question. Y equal 1 minus exponential minus x over 1 plus exponential minus x. Find the derivative of the function. Then you should find the gradient of the graph of y at the origin. Means what at the origin? Means when x equals 0 and y equals 0. So when x equals 0, it will be 1 minus exponential of minus 0. It should be 1 minus 0. And 1 plus exponential of minus 0 is 1 plus 1. So it will be 0 divided by 2. It will be 0. The y value is 0 and x is 0. This is why the function the y is at the origin. Okay, means if you replace x with 0, you will find y so is 0. That's why it's called find the gradient at the origin. Okay. Now we continue like that. Where we page 25. Okay. Okay. Now we'll do like that, learners. Okay. I will paste here. Origin. I paste this here. See the solution. Okay. I will just okay, Control A. I will make it. This is solution done this. Okay, but I will appear like that. Okay. Now we continue. We told that I should simplify this one. Now I can extend because I have space. Okay. So I told that I will make dy with respect to x is equal to. Okay, now we'll just simplify this as possible, where possible. dy with respect to x will give me 1 multiplied by exponential of minus x. It will be exponential of minus x. Okay, so I'll just write it here. Instead of writing 1, I will write exponential minus x. Then exponential minus x multiplied by exponential minus x gives exponential minus 2x. Then I can erase this one and Then we move to the next one. Minus multiplied by minus is positive. First step. Okay, this is minus by minus, it's positive. Now exponential of minus x multiplied by 1 is exponential of x. I will just copy this, cut this, okay, plus we call exponential of minus x. Okay, and then what else? We told that this is exponential minus x. Okay, just check this again. So we told v u dash v, this one multiplied by the first derivative, yes, is correct here, and minus v dash is minus exponential of x, multiplied by 1 minus u, which is 1 minus exponential of minus x, correct, okay. All divided by 1 minus exponential minus x all squared. Okay, we continue. Therefore, we told this is exponential minus x because this one multiplied by this gives exponential minus x, and exponential minus x multiplied by exponential minus x is exponential minus 2x. Then minus multiplied by minus is positive. That's why we wrote the positive side. Then exponential of minus x multiplied by 1 is exponential minus x, and exponential, let's say, of minus x multiplied by minus exponential minus x gives me exponential of minus 2x. Okay, but you can see that exponential, this one, okay, I will change with other color if it is possible. So exponential minus exponential minus exponential minus 2x plus exponential minus 2x is equal to 0. They will be cancelled automatically. Therefore, it remains only exponential of minus x plus exponential of minus x, all divided by 1 plus exponential minus x squared. It will be 2 times what? 2 times, okay, it will be 2 times this one like that, okay. So I will change this as that, okay. Yes. So this one, learners, is in fact equal. I will now write all of this again, copy, and the last answer is that. Okay, the last answer, learners, is that. Okay, equal. Okay, now we told 2 times exponential, 2 times exponential minus x. Why it doesn't come? Okay, plus. Okay, this is, we told that exponential minus 2x minus exponential minus 2x is 0. So this is last answer. Okay. If you want, let's say, to change this, okay, it will be, okay. So this is the last answer. We consider this the first derivative of the function. Okay, I wish that it's clear for you, and the explanation, it's clear for you. Okay, just when you suppose or consider u equal 1 minus exponential of minus x, therefore you should differentiate y, u dash, which is equal to minus multiplied by minus is positive of the function exponential minus x. And when you consider v equal 1 plus exponential minus x, v dash is minus the first derivative of the function x, it will be minus, then you are going to write exponential minus x. Therefore, to find this one, you are going to multiply, let's say, v, this one, v by 1 by exponential of minus x. This is v multiplied by exponential minus x. Then negative sign in the formula. Then v, which is minus exponential minus x, is written here, multiplied by u, which is 1 minus exponential minus x. Therefore, it's clear for you. How can you find the first derivative of a quotient? Okay. Now we move to the next part. The second question told you that find what exactly? This is A, okay. B, find the gradient of the graph on the y at the origin, means at y equals 0 and x equals 0. Just you will replace the value of x, you replace the function, first derivative of the function with x equals 0. Okay, so this one at x equals 0, I'll just use this one. Okay, I will write now as y dash because I don't have a lot of space. Okay, I will just use y dash instead of writing dy with respect to x. Therefore, y dash at between parentheses at x equal we told equal 0, okay, at the origin, and y equals 0. So I will get this one. I will get y dash, which is equal to, in fact, 2 times exponential of minus 0. I will do it again here. Okay, it will be equal 2 times of exponential minus 0, okay, minus 0, which is 0 in fact, minus 0 here also, which is 0 in fact. Okay, it will be equal what? 2 times 1 divided by 1 plus 1 square will be 2 divided by 4, which is equal to, I will just write it here as equal equal to divided by 4. Okay, or I will write it down. Okay, I will extend this. I will write this down. So we told that this is equal to, in fact, okay, equal to exponential of minus 0 is exponential of 0, which is equal to 1. And 1 multiplied by 2 is 2. Then 1 plus exponential of minus 0, it will be 1 plus 1, all squared, it will be 2 squared, it will be 4, divided by 4. Therefore, now the gradient learners is equal to 1 over 2. Okay, 1 divided by 2 or 0.5, whatsoever you understand, equal 0.5, or you can write as 1 divided by 2. This is the gradient. Okay, so this is learners is the gradient. Okay, means m in fact is equal to the gradient small m is equal to the value of y dash when x equals 0. Okay, I wish this is clear for you, learners. Okay, now move to the next part. Okay, learners, please try to revise. Okay, because it's very important, these questions. Okay, and exponential will come sure in the exam. Okay, as exponential sine of x, exponential cosine square, tangent square, and you should differentiate the function, and you should find the stationary point, and so many things in fact you should think about. Okay, now we move to the next part. We have given that z1 is negative 2 root of 3i. The question is, write z in the exponential form. Okay, this is the given function. Here, learners may will be asked about to raise the complex number z to the power 3, 4, 5, and so on. And you should, let's say, know about the Euler's identity and the Euler formula, and so the Moivre formula, because the Moivre formula, it's very important when n is more than 2, means the power. So because it will give you exactly, for example, z to the power n, which is equal to, if suppose that the complex number z is x plus iy, and is written in terms of exponential form, it will be r exponential I theta. To raise this to the power n, you will make z to the power n is r to the power n, because exponential of I theta all to the power n. Then you should multiply the argument by n. It will be r to the power n times exponential I n theta. And this theorem or this formula is very important because you are going to immediately or automatically, means automatically, automatically, or automatically going to multiply the angle inside the cosine and sine when the complex number is written in the polar form, means like that. I will try to explain this before uh, solving this equation. Okay. For example, learners here, we have this one. This is very important. Sorry. Go back, Mr. Murad. Go back. Okay. I put this like that. This is the question. Now, learners, you should know that if z, or I will use this one. Okay. Yes. If z, learners, is equal r exponential theta, I theta, of course, exponential I theta, exponential I theta, okay, or I multiply by the argument of z, r v of z. This is the argument of z, and r in fact is written as the modulus. The modulus, I will try to find the modulus here. It is possible. Yes, I found it. I thought. Good man. And this one, yes, this is the modulus of the complex number z. And r here is the same as the modulus z. Between parentheses, I can write here. It's written also as, it can be written as r also equal r exponential of I theta. Okay, exponential I theta. Okay, and r here is the modulus of the complex number z. Okay, and be careful while, let's say, theta is in the first quadrant, it will be the same. If it is in the second quadrant, you should, let's say, make pi minus the angle theta. If it is in the third quadrant, you are going to make, let's say, minus between parentheses, pi minus theta, which theta is in fact the tangent of the net minus 1 of b over a. Okay, if it is in the fourth quadrant, you are going to, let's say, reverse the sign of this angle. It will be negative. Okay, means argument of z is negative theta. Okay. Now, learners, if now you are going to write this, of course, if you want to raise this to the power n, learners, you should know that this one, in fact, also equal r cosine between parentheses, r cosine theta. Okay, we'll use this one, cosine theta, plus what? Cosine theta plus I sine theta. Okay, of course, here there is, okay, IR multiply this one. Okay, I'll make here enter. And this is the explanation before started. Okay, now learners, if you want, let's say, in the form, exponential form, okay. Therefore, now if you want to raise this to the power n, you will make like that. I will just, how can you proceed? I will make now z to the power n. Okay, z to the power n, or I will write first cosine and theta plus, what comes back to the question, plus I sine and theta, okay. I will close the parentheses, and this is all multiplied by r to the power n or exponential, or the modulus of the complex number raised to the power n. This is r to the power n, okay, whatsoever n is an integer, and this one, in fact, is equal to z to the power n if you are going to raise your complex number, and this one is equal to z to the power n. Okay, Therefore, this formula, it's known as exponential. Okay, it's known as exponential. Uh, Sorry, it's known as De Moivre formula. Okay, I will write it here. This one is equal also to r to the power n, or I will make parentheses. Okay, Control V. I will close this one. This is equal r to the power. Let's say I will just write r exponential. I will make another here exponential. Yes, like that. Exponential I argument of z or I theta. What is theta? This one. Okay. Okay. All to the power what, learners? All to the power, sorry. All to the power n. Therefore, I will try to erase this one. It is possible this interval doesn't work. No problem. Notification once you share your screen. Details slow. Details are hidden while you share your screen. Okay. I'll check the screen. This formula very important. It's called the Moivre. I wanna be yours. TikTok. Okay. Therefore, learners we told that it's called what the Moivre formula means. This n comes like that. You should raise r to the power n, then replace e I theta by cosine theta I sine theta, but should be multiplied by n, so like that. Rn cosine theta plus I sine and theta. This is the De Moivre formula, but let's say the Euler's formula is written as exponential Ix only. Okay, so this one we told it's called the last one. It's called De Moivre. I'll just write B M F means De Moivre formula. Okay, now if we are going to proceed to continue, I will just write this as Z is equal this one. Okay, I will write it here. It's possible, of course, learners. This one Z equal, okay, Z exponential Ix. The X is a real number. Okay, and the modulus of z in fact is 1. Okay, it will be exponential of what? Exponential of Ix, which is in fact all the values of the x are lying on the unit circle. Like when x equal pi, it will be exponential I pi, it will be -1. When x equal, let's say, pi over 2, it will be, the complex number z, let's say, located, or should be plotted on the imaginary part, let's say, measured from the real positive real part, okay, to the imaginary part, which is positive. And therefore, this one is equal to cosine x plus I sine x, sine x. This formula, learners, it's called Euler formula. Okay, this one is called Euler formula. Okay, Euler's formula. Okay. In fact, the De Moivre and Euler, let's say, these two scientists are working together in the past, and Euler formula helped De Moivre to generalize the formula. Okay. and this is, we told it's a Moivre. I will just write it like that. I will write the name of this scientist, Moivre. Moivre, okay. Formula, 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 okay. I will just extend this, learners. If it is possible, you should excuse me, okay, to explain this for you. And for the identity Euler formula, I will just write this again. I will write this again, learners, okay, to show you the Euler's identity. Okay, Euler's identity, it's a particular case. So it's helpful to work with, but in the final exam, it will come as find the value of I to the power 4, I to the power 2, and so on, like that in general. Okay. And I will just write here, it will be IP. I am looking for the angle pi, sorry, an angle pi, okay, which is equal to, in fact, to it will be z, of course, is 1, okay, modulus of z is 1. This one, learners, is equal to what exactly? I will write it in terms of cosine. It will be pi, okay, copy. It will be, let's say, this is the angle pi, plus I sine pi, okay. And this one, it's called what? It's written as minus. It will be equal minus 1. Therefore, this one, I will just write again. Therefore, Euler formula are 2 points. Euler formula is Euler's identity is that is following. Oh, sorry, is plus I plus sorry, where is it? Sorry, again, I will go back. I will go like that, okay. We told equal minus 1 or plus 1 equal 0. This is the Euler formula, this one, the last one. Okay, it derives when he puts x equal a pi, okay? And all the value of this angle x should be lies on the circumference of the circle, okay? Now, learners, I'm going now to solve this question, right? Okay, I will give you a slight idea about some, let's say, knowledge, okay? Now, the question is that given z equal negative 2 root of I, okay, 2 root of I, my God, what happened? Okay, means that the real part is 0 and the imaginary part is negative 2 root 3. Therefore, I will come here to continue solving, learners. I'll just make, okay, now we have more than 1 hour, my daughters and my kids, boys, okay, this is a complex number that I'm looking for to write it in exponential, I thought exponential form, yes. Okay, I will start doing it now. Okay. So first of all, okay, yes, this one. First of all, learners, you should write your complex number, which is that z equal negative root of 3i, which is equal, in fact, r, or the modulus of z as you like. I will write modulus of z, no problem. Okay, because it's important for you to understand is modulus of z, okay, modulus of z, exponential, okay, exponential, of what? Exponential of I theta, or I argument of z, argument of z. Okay. Now, first of all, I should find the modulus. Therefore, the modulus is root of, it's clear that, therefore, modulus of the complex number z here gives me exactly equal the root of, I will use root of what? Of a negative 2 of, sorry. Okay, I will use only this one, yes, minus, oh, good man. So, root of, between parentheses, negative, control V, negative, I should square this one. Okay. Okay, no problem. I will cut again. This one I will cut it. So I should square this number. Okay. Now it will be clear. So to the power 2. Therefore, this one is equal what, learners? Minus 2 square is 4. Then 3 root of 3 all square is 3. 4 multiplied by 3 is 12. So root of 12. Okay. It will be root of 12. And root of 12 is 4 by 3. Okay, it will be root of 12, which is equal to root of 3 multiplied by 4 gives 2 root of 3. I will use just this one. Okay. So this is the modulus of the complex number z. Okay. I'll just check again. We have z equal okay, real part plus I imaginary part. So the imaginary part here, negative 2 root of 3. You should square this number. It will be root of minus 2 root 3 squared. It will be 4 multiplied by 3, 12 root of 12. Yes. So this is learners is let's say okay, is my modulus, or is R. Okay. Now I'm going to find the angle. Okay. So tangent, I just use, I will, okay. I will make like that. Okay. Now I should find the argument of z or the tangent. It is minus 1. I will use this one. Copy. I will use tangent or argument of z, or I will make theta first. Theta, or is it theta, this one. Okay. Theta is equal to 10 minus 1 of 10 minus 1 of this ratio, of this numbers that is at in service. Minus 1. Okay. Of what? Of 2 root of 3. Okay. So we use calculator. In fact, is minus, but you should put into, let's say, as an absolute value. Okay. Make shift 10 2 times root of 3. Okay. So it will be 73.9 approximately equal. Okay, 73 point what? 0.80 0.89 0.9. Okay, 0.9 degree. Okay, if you want to change this to radians, it's clear. You are going to write is equal to 73.9 approximately, multiply by what, learners? Multiply by pi over 180. This is pi, 100 pi. I'll make pi, this one, divide by 180. Okay, 180 degree, of course. What is the symbol of degree? I lose it again. Yes. I will use calculator. It will be, so it will equal divided by 180. Okay, multiply equal multiply by shift by equal 1.29 approximately equal 1.29 radians. Okay, so this is the angle, learners. Now, if okay, now I can write, let's say, my equation. Okay, this is the angle, but you should know the minus 2 root of 3i is in the, let's say, in the fourth quadrant. Okay, so it will be minus. Just a moment. Okay, for this kind of questions, I will just write this is pi over 3 pi over 2. Therefore, learners, I will just explain this for you. Okay. Here we told the real part is 0, therefore this one locates on the imaginary part, so it's negative, so to the angle theta it will be let's say 3 pi over 2. Therefore theta is 3 pi over 2, yes, because the real part is 0. Okay, I'll just write here 3 pi over 2 or 90 degree. 3 pi over 2. I will explain this for you, just give me time. Okay, over 2. Okay, now learners, if we suppose that okay, I will go to paint. What is paint? This is paint. Okay, extend this one. I need okay. Okay, I need this one. No. Okay, I will need another. Okay, then I will cut this down a bit. Okay, then I will cut also this down it. So this one, learners, is the real part. I will try to write it if it's possible. Pencil. This is imaginary part. Imaginary part of the complex number z, and this is the real part. So the real part, it's clear that is 0. Therefore, you are going to see the sign of the imaginary part. If it is positive, so the angle is pi over 2 or 90 degree. And if it is even, means it's a negative pi over 2, or also it's 3 pi over 2. Therefore, this is, of course, this is the 0. Okay, this point is the 0. Now the angle, from this to that, it's called the real part of the real part of the imaginary part of the complex number z. This is negative 2 root of 3. Therefore, this angle, in fact, learners, is 3 pi over 2. Okay, you get the point. This one is, okay, is 3 pi over 2. If now, learners, for example, this is if we suppose that z equal negative 2 root of 3. Okay, so Of course, I, the imaginary part is I, don't forget. So this complex number is located on the uh, let's say the imaginary part axis, but below zero, this one, and the angle is 3 pi over 2. If we suppose now z is equal to, for example, 2 times root of 3, okay, multiplied by I. Therefore, learners, this one means the angle is pi over 2. For example, 5 root of 3i would be pi over 2. So therefore, that's why here the angle I consider as 3 pi over 2. Now I can write my angle now, and I will just write this as that. Okay, I will write this. Therefore, z is equal to let's say the modulus is 2 root of 3, 2 root of 3, copy and paste, equal to 2 root of 3. Okay, exponential what? Exponential of the angle, exponential of the angle 3 pi over 2. Okay, and I will show you this one, how it works. Okay, multiply by I, of course. If you are going to write this as this is exponential form, if you are going to write it as polar form, you will write like that. Okay, copy and complete and paste. And I'll make this one multiply between parentheses cosine of what? Of 3 pi over 2. Oh, Mr. Murad. Okay, very awesome. Okay, plus I times sine of the angle this. And therefore, you can note that cosine 3 pi over 2 is 0. Okay, so this one gives you, in fact, 2 root of 3, 2 root of 3 equal 2 root of 3. Okay, multiply by I, sine 3 pi over 2 is minus 1. Multiply by minus 1, I. Okay, multiply by minus I. Simply because, let's say, sine 3 pi over 2 is negative 1. Therefore, this one is equal to what, learners? Will give us negative 2 root of 3i. Okay? Thank you for listening, learners. I was very exhausted. Okay, I wish at least I gave you some ideas. How can you work and how can you be familiar with complex number and with the differentiation? Okay, let's focus on this question. So at least it's clear for you. How can you figure out the answer? Okay, now learners, I'm going to find the value of z to the power 5. My God, z to the power 5. Okay. Z to the power 5, okay, means that you are going to use the Moivre formula, okay, or you are going to write, I will give you the method, okay. The first method is that, okay, this is the first method. Okay, I'll put it here. Go back, Mr. Murad, go back. Doesn't work. Why? Okay. Okay, now it works. The question is that find z to the power 5. Okay, I will type this. I will write it here. Find the question is, this is the question. I will write it here, learners. This is the question. Therefore, to find this, learners, I will use this one. Okay, means I will use this one, learners, or you should okay, equal this one. Therefore, I will just write it. I will solving solution, answer as you write answer. So, okay, 2 points. I will start. I will write z to the power what? Z to the power 5. copy, and here z to the power 5 known means that you are going to erase this. Okay, raise this to the power 5, which is negative root of I. Okay, like that. I will erase this one and make minus. Okay, now I will erase the rest. Okay, therefore, learners, to find z to the power 5 means I will erase this. Okay. Mhm. So this is no need. Okay, equation, this one, I will make, I'll check now, I will make parentheses, this one, the parentheses to the power 5. So, means that you are going to raise this one to the power 5, multiply by I to the power 5. I'll just write this as equal. Okay, between parentheses, of course, I'll make this one. Between parentheses, I will make known as this. Okay, I will just erase the y, the I, close this to the power 5, multiply by another. I will erase I to the power 5. I to the power 5. Okay, I to the power 5, it's clear that it will be, first of all, this one I can, let's say, calculate it, minus we told between parentheses minus 2 root 3 all squared. Okay, to the power 3 we told. I will close parentheses all to the power 5. Give it in fact negative approximately. Okay, give us negative, okay, give us negative equal negative 288. Okay, root of 3. Root of 3. Okay, now this is the answer. Okay, but I should also check that I squared multiplied by I squared multiplied by I is I to the power 5. I squared is minus 1. I squared is minus 1. So it will be multiplied by I. Okay, this is the first method. The second method is, as you wrote z in terms of exponential form, you just raise this to the power 5, and you can use the Moivre formula. Therefore, I will just consider this. This is the second method. Okay. Okay. This is first method. First method. Answer comes down. First method, I will use equation. First, okay. First method, F1 ST4. Okay. Method. Okay. Now I use second method, so that you will be familiar how can you work this or answer this kind of questions. Whatever, let's say the method, the main important thing, you did it correctly. Okay, this is second method. I would do it like that. Second method. Second method. Okay. Now I will receive a complex number z. Okay, I will raise this to the power z to the power 5. Okay, copy like that. I will make this is equal to. Then I will erase all the rest. Okay, therefore, this is, of course, is implies equal, implies that. Okay, so I just write 2. This one I need it on this z to the power z to the power 5. Therefore, 2 root of 3 to the power 5, I will write like that, equal. Okay, equal this one. Okay, okay, equal this one. I will use this one because I did before for the modulus. Equal this. I will write this negative sign. Okay, then multiply by what? Multiply by exponential 3 pi over 2i all to the power 5. Okay, this one I will make like that. Okay, this one x and to the power 5. 5. Therefore, this one is equal what, learners? Just the Moivre formula told you that the power should be multiplied by the index of exponential. So this one will give me exactly, I will make like that. Copy again, which is equal to 5 multiplied by 3 is 15. Is 15. I will just raise this one. I will make exponential. No, I will make exponential. Okay. Again. Just I will go back. Oh, I don't have space. Let me see. Yes. Okay. This one equal what? I will write this in the front. Okay. This is in the front. Okay. Now we told that z to the power 5 will give me exactly. This is z to the power 5. It was erased by mistake. Okay. Equal. So also therefore I will write it here. Therefore. I will do like that. I'll come and see exactly. Now, and yes, Murad. Okay, this is exactly that's what I'm looking for. I will write here Z. Okay. I will told I will erase this one, or I'll make, yes, I will make this one. Where is it? This exactly that I'm looking for. Okay, on the 15, صح? Erase all of this. Okay, so we told that 5 multiplied by 3 pi over 2 is 15. 15 pi. Okay, now learners, this one will give me exactly 288 root of 3. Okay, root of 3. Multiply by exponential of 15 pi 15 pi over 2. And this one, when let's say you turn the unit circle or the whole circle, let's say 15 times, the number is odd. Okay, means the first okay, it will be negative simply because this one can be written as 14 pi plus pi all divided by 2. 14 pi divided by 2 is 7 pi. So the number is odd. Therefore, the negative sign will appear. So it will be negative 288 root of 3 multiplied by I. So this is learn the last answer. And whatsoever the method, okay, you can use also the third method. You will use what? You will use cosine. You can also use cosine of 15, let's say 2 root of 3 to the power 5, cosine of 15 pi over 2, which is in fact 0, plus 2 root 3 to the power 5, sine of pi, sine of 15 pi over 2, okay, and okay, therefore sine of 15 pi divided by 2 is negative, therefore the negative sign will come. Oh, right, like that, I mean. Okay, it will be 2, copy, 2 root of 3 multiplied by cosine of 15 pi 15, or is it 15? No, that has to 15 small. This one, okay, 15, yes, 15 pi plus what? Plus sine, okay, plus sine, of course, I sine of 15 pi, then close the parentheses. Learners, this one cosine 15 pi divided by 2 is 0. And you can use calculator, you make 15, you may make a sine, sine 15 pi, okay, or 15 multiplied by pi over 2 is 90, multiplied by 90 degree gives -1, okay. So this one is equal, in fact, to, I will write it down, or how, okay. So it will be, okay, I will, okay. So it will be this one, we call this cosine 15 pi over 2. We can write, use a calculator, make cosine of 15 multiplied by 90, it will be 0. Then here I sine of 15 multiplied by 9 to give us -1. And -1 multiplied by this number that is written inside this, which is 288 root of 3, multiplied by -1 will give you this one, okay. Thank you for listening, learners. Now let's say spend more than 2 hours for you, learners. I wish that you are okay, and see you next time, inshallah. Okay, I promise you that I will continue revising with you, and it's a promise, and I will never postpone this promise. Okay. And here, for this question, think of this will be done for tomorrow. Okay, prove that 1 minus 1 cosec all square plus cosine square equals 2 minus 2 sine square. Okay, thank you for listening. Okay, I hope that you got the point at least. How can you work with some questions? Okay. And now we're going back to the stream to stop on the stream. Okay. And the stream. Yes, I'll stop sharing first. Stop sharing. Facebook, other friends have. Okay. Thank you. So, learners, see you inshallah tomorrow if it is possible, of course. Okay. And I wish that I had you at least, even if you are at home or you are in a trip or you are, let's say, camping somewhere, your mathematics teacher, your pioneer methods is here to evolve your levels and to improve your knowledge and to improve your understanding, because math is understanding, not learning by hearts. Okay, and just take a look for the revision, and if you have questions, don't hesitate. Your mathematics teacher, your pioneer in methods is here. Even if I am the moon, I am, let's say, on the moon now, and you ask it for answering a question, I will immediately, let's say, take my spacecraft and will be going to land on the Earth so that I can answer you. Okay, thank you and goodbye. I love you so much. Bye bye.